Hello again, welcome back. What we want to do today is to look at Kirchhoffs laws, and what I'm hoping to do is to show you how Kirchhoffs laws can be interpreted and how to go about solving circuits or calculations which involve Kirchhoffs. Now, one of the things I want to do first is to begin to show that Kirchhoffs laws can be applied and can be resolved once you have applied yourself to the principle that you follow in the steps as laid down in each case. Now, Kirchhoffs laws relates to the calculations of current flowing through a closed loop circuit. Okay? Now, it allows us to calculate the current in each resistive part of the circuit where there is more than one source of EMF, electromotive force, is being applied. Okay, now that's to say a circuit where you may have two batteries providing 5 volts from each battery in a circuit, which we will look at in more depth a little bit later. But for now, we need you to understand how the laws are applied and how to set about applying and resolving for the purpose of calculations. Okay? Now, it is important to remember that a current arriving at a junction of a circuit is equal to the current leaving it. This means if you have 5 amps arriving at a circuit, you must have 5 amps leaving it. This means that the algebraic sum of the current must equal 0 at the point of the junction. Let us consider an example. Here I've given you a figure Z1, and in Z1 we start sequentially. So we have I1, I2, I3, I4 and I5. Now, in the case of I1, we have current going into the circuit. In the case of I2, we have current leaving the circuit, or more appropriately, leaving the junction. In I3, we have current leaving the junction. In I4, we have current coming into the junction, and in I5, we have current leaving the junction. Okay? Now, it is important that you write down the information given above so as to aid your own individual understanding. Now, this is important. You must write out the information so you can understand it yourself. Do not try to retain it in your head. It doesn't work. Because what you write down, the brain never forgets. Draw out diagrams and put in the relevant currents as shown. Now, if we consider the algebraic sum of diagram Z1, which takes account of the current in sequential form, that is to say I1, I2, I3, I4 and I5, this would be sequential. Okay? So, the solution for figure Z1 would be I1 minus I2, I2 minus I3, I3 plus I4, I I4 minus I5 should equal 0. Now let us prove this. To prove this, we can put in given values of I. So what we're going to do, we're going to put in the values of I, drawing another diagram which we are going to call Z2. So using the information from Z1 as previously stated, I1 minus I2, I2 minus I3 plus I4 minus I5 equals 0. Okay? Now here is a diagram which we have now put in the currents which is flowing respectively into and out of a given junction, and we're going to call this figure Z2. Okay, here we have I1 equals 5 amps going into the junction, I2 equals 3 amps coming away from the junction or leaving the junction, I3 equals 4 amps leaving the junction, and I4 equals 7 amps going into the junction. I5 equals 5 amps, and that is leaving the junction. Okay? Now the values have been put in so you can see from diagram Z2, figure Z2 if you prefer. You can see that I1 has a value of 5 amps, I2 has a value of 3 amps, I3 has a value of 4 amps, I4 has a value of 7 amps, and I5 has a value of 5 amps. Okay? Now please note, A mean amps, that is the current flowing in an electrical circuit, okay, in this case. Now that we have been given the currents flowing in the circuit, we can now put it in numerical form. So 5 minus 3 equals 2. 2 minus 4 equals minus 2, because 2 take away 4 will leave you minus 2. Minus 2 plus 7 is going to equal 5, because 7 minus plus and a minus makes a minus, so you're subtracting 2 from 7, okay, which will leave you 5. And 5 minus 5 will equal to 0. And that shows that by adding or subtracting our currents, arriving at the junction, that the result should equal to 0. Or we can simply say also I1 plus I4 minus I2 minus I3 minus I5 will also equal to 0. The negative sign for I2 denotes the current flowing away from the junction. So all the current flowing away from the junction is then summed together, which should equal the current coming in. When the appropriate calculations are carried out, the result should be equal to 0. Okay? And that should be in your result. Just checking I have not taken down anything further. Okay, and that will be it at this point in time. Now I will follow up this and show you examples of actual circuits with resistors in the circuit, and then we can see how the process of actually calculating this current in the circuit when there's 2 batteries applied. I will apply this as an ongoing process. This is simply the first element or first stage of a little bit of Kirchhoffs.